Hi there, my name is Chris, and this is my partner Kevin and I's EE445L final project, where we get to design, build, and test our own embedded system. And I'm going to walk you through it here. First thing you'll probably notice is this whole mess of wires over here. What this mess is that the processor that we originally designed our embedded system around was the LM3S811, and if you don't already know, it is a surface mount component, which means it is very difficult to solder on. And so through the soldering process, well, I'm not sure if it was the soldering process, but somewhere along the way we weren't able to program our processor on once it was on our PCB. So we had put header holes on our PCB, so in the case that our onboard processor did not work, we could run all these wires and run it off of an LM3S 1968 evaluation board, which you can see over here. Another thing you might notice are these buttons that are on this proto board here. Originally we had some buttons in these holes right here. We had these push buttons, but the bounce on these were too bad to compensate for only in software, so we ended up going with substituting these for these push buttons down here that have much less bounce and work a whole lot better. So what our project is an LED drawing pad, and I'll go ahead and turn it on. It's powered off of a 5-volt regulated supply coming from this cable here, which is connected to a wall wart plugged into the wall. So here it goes, and the first thing you'll see is the startup sequence, where what it does is it scrolls through all of the LEDs and all of the possible colors, so you can tell, basically verify that everything's working. And on the LCD screen here, you'll see through that startup sequence it has the message starting up. So now what the LCD screen says, it's kind of hard to make out, but it says move around. And so using these 4 directional buttons here, you can move the LED around. So you can see it moving around. One press down moves it one coordinate down, and so forth. So you can move all the way around and verify that everything's working. Anyways, the whole point of this is that it's a drawing pad, and so each one of these LEDs on here is a different is a RGB, meaning it has red, green, and blue elements in it. So you can either pick one of those colors individually or combine them in any way. And so through a user interface menu on the LCD screen, you can select which color you want to draw with. So how about I go ahead and do that? And so a message pops up saying select a color, and then you can scroll through the menu. So let me start off with red here. And then when you press the menu button again, it displays drawing mode, so it lets you know that you're in the drawing mode. And this white LED here is kind of your cursor, so you know where you're at and where you're drawing at. So move across, so there you go, you got your red going on there. So let's try a different color so you can show that you can have multiple colors on there at the same time. Let's go yellow. And when you're scrolling through the menu, once you're on the color you want, you just press the menu button again. And so, see, you can get, it's a little hard to tell in the video, but that's yellow. And let's get one more color. Let's go for blue. So now you got some blue on there. Alright. Also, what we added into our project was some preset patterns that are stored in memory that you can display on the LED array here. So let me bring one of those up. First thing here is a longhorn hook'em. Next thing are the letters U and T, and got a smiley face, and when you go into it multiple times it picks a random color, so that's kind of cool. Also, we have this pretty cool looking mode called random colors, where it'll pick random coordinates and pick a random color and kind of keep changing everything. So it's a lot more interesting to see in person, so just come check it out. I think let me go into a little bit about the theory behind how we design this. So one thing to take into account for an embedded system is you want to make it as low power as possible and use as few I/O pins as possible. So the key to doing that, with all of these LEDs, we use this we use this process called time division multiplexing. And what that's doing is, instead of powering the entire all 5 rows of LEDs at the same time, because that would consume a lot of power and require a lot of I/O pins, we actually cycle through the rows one at a time, and power one at a time, and have all the anodes on a row connected, and then also have the cathodes for every color connected in each column on the way down. So that reduces the number of ICs that are required and reduces the power consumption, because you don't have to power everything at once. Alright, I think that's about it. If you have any questions, post a comment and I'll try to get back to you. Thanks.